After over 2 years, and with the mileage getting close to 10,000, I thought it was time to make a video about my bicycle. And it's CVT, provided by NuVinci, or now known as enviolo, and the Arduino controlled fully automatic shifting system. So what's a CVT? CVT basically means I've got an infinite speed hub. And one of the things I like about that is that I'm not restricted to gear ratios. Within an upper and lower limit, I can get any ratio that I like, and so maintaining a perfect cadence. One of the other things I like is its reliability. Why is it so reliable? Because it's so simple. Here we have the input traction ring, the output traction ring, the shift mechanism, the stator which holds the planets, and this is a planet. The ratio is determined by the angle of this axle. Here I have cut away a section of the hub, obviously removed the traction fluid first, so that you can see what's going on. And now I'm taking the bike for a ride. The input RPM will remain fairly constant, whilst the output RPM, or wheel RPM, is gradually increasing, and there we have 1:1, and now the wheel RPM has overtaken the input RPM. Just a smooth, gradual transition, no steps. And here from a different angle we can see the stationary parts, or stator, and the two traction rings, input and output, rotating around it. Just wanted to say before I continue the video that it is possible to buy an automatic shifting system for these hubs called Harmony. It is quite good. There's the handlebar shifter. I'll put a graph on the screen showing that it maintains a cadence more accurately than mine does. Obviously it doesn't come with a power meter connection or the ability to use more than one chainring. So it all started when I wanted to put a CVT on my road bike, and soon realised that this wasn't going to fit the handlebars. If I was going to make the shifting electronic, then I thought, why not make it automatic? I'd heard about these circuit boards called Arduinos and wanted to learn what they were all about. With a hub that effectively has an infinite number of speeds to choose from, it sounded like a perfect job for a microcontroller. This is the original shifter that I made, including a real planet. Underneath there is a potentiometer. At first it was just a way of changing the value sent to the servo, so like manual electronic shifting. Then when it was automatic, it became a way of changing a value in an equation, and so I could select cadence with it. I then created this, which sat here on the bicycle. Inside is a linear potentiometer. The cable is pulled by a standard shifter. In the Arduino code I had a range of values for each cadence setting, and because the shifter's indexed, it would shift to a value which I would set so that it was roughly halfway in the middle of each range. But I rather liked it, and it worked pretty reliably, and the fact that I could just use the standard shifter was a big improvement on fiddling with the potentiometer, and it was waterproof and worked great. I'm now using these two buttons hidden under the hood, one for changing the setting up and one for down. If either button is held down, it will go back to the middle setting. That will either change the cadence setting, or if the power meter is connected, it will change the power against cadence equation. A front dynamo hub. With the more efficient hub interface, I've actually managed over 1,000 miles now without charging it off the mains, so that pretty much keeps up with the charge. Inside there is basically one of these servos. They are easy to get hold of and replace. But so far the one that's in there has done almost 10,000 miles. It's been super reliable. It's got 20 kilograms per centimeter of torque, which I believe is about a third of what Harmony uses. To the hub interface, and I've built my own direct drive hub interface for lower resistance and less slack in the system. There's nothing wrong with these plastic ones. I used them for a long time, but they just do have a bit of slack in them and they do wear out. There's the important reed switch, the wheel RPM one, and its magnet there. Around the back is the cadence sensor and also its magnet. Harmony uses 6 magnets and a Hall effect sensor. I personally found reed switches to be very reliable, and because they are designed to work with a bike computer, they fit nicely on the frame. Here's the power meter, which makes it fully automatic. Otherwise, without that, it's just constant cadence. I'll make a separate video about it. It's too much for this video. Currently testing it against these Garmin Vector pedals. I haven't got proper shoes, which is why the cleat is there to provide a flat surface. Around here we have the derailleur reed switch and its magnet. That tells the Arduino which chainring I'm in, so that it can change the hub ratio and maintain a constant cadence. On to where I keep all the electronics. The Arduino, LiPo cells, and that's the 9-pin connector that comes from the bicycle. That's all the inputs, outputs. I'll make a separate video on that one, explaining in more detail about that. Eventually I want to get it small enough so that it fits in the box there with the servo, and also get it communicating with ANT+, so it can pick up power data off any other power meter, maybe even cadence and speed sensors. And then I want to experiment like BioShift are doing into different algorithms for power against cadence. And that's my ultimate goal for the project.